What if malware could think, adopt, and evolve its attack strategy in real time based on your system? What would then happen? In today's Threat Talks The Deep Dive, we dive deep into Promptlock, which does exactly this. So let's get on to it.
Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity.
With me today is Yuri Wit, our SOC Analyst, and I've done an episode with Yuri before on AI and deepfakes. So welcome back, Yuri.
Thank you for having me.
So, and my name is Rob Maas, Field CTO at Ontoit. So Yuri, when you did hear about Promptlock for the first time, what was your immediate response?
Initially, I was surprised, then shocked, and then a sense of dread came over me because I realized that my job was going to get a lot harder very soon.
So this is already an indication that Promptlock can really change the way we are looking at security now.
Definitely. Yeah.
Okay. But before we go into Promptlock, AI is already being used by attackers for quite a while now. Can you give us some insights in the current techniques that attackers are being used?
Definitely. Yeah. So the most obvious example of AI being used by cyber attackers is in the generation of phishing content, either the content of a phishing email or phishing SMS or whatever. A lot of groups already use AI to generate that content because it can really easily just be changed based on initial parameters. What kind of company is it that we're trying to target with this message? Who are we trying to target with this message within the company? Things like that. Using AI, you can very easily just change the content of those emails.
And also
on the
make
fly.
Sure that the English is correct
Exactly.
or the language
Spell
that
check.
you want to use.
Yeah.
Okay, and any other techniques that we already see?
Yeah, so obviously AI coding assist, you don't really hear this often, but we can very safely assume that since AI coding assistance is already being used widely by software developers around the world, we can assume that cyber attackers and malware developers are doing the exact same, but you don't notice that, of course. And a third method that we've also seen here and there is the use of AI in the negotiation between an attacker and a ransomware victim to negotiate price, delivery, all sorts of aspects. Again, most likely to fix their English spelling, but also because it obscures the attacker a bit. Talking to an AI chatbot is very obvious, but it's not fingerprintable. You can't really determine to which attacker you're trying to talk to if you're talking to an AI.
Mm-hmm.
Yeah.
Okay. So AI for attackers is not new, but what is different now then with Promptlock?
Well, with Promptlock, we have seen that while the other techniques used AI either in a stage before the attack or a stage after the attack, with Promptlock, we have seen AI being used during the attack, during the actual execution of malware. AI was being used, and we've never seen that before.
Okay, so this is really a new era, I would say, of malware and the use of AI within that.
Yeah.
So can you help or guide us through the steps that Promptlock takes?
Yeah. So initially, Promptlock just executes like any other malware. It is written in Golang and it's compiled to multiple different platforms. So it could just be a Windows executable, pdf-cider.exe.pdf or whatever. Once it executes, it will start to send requests to an Ollama server hosted by the attacker to request inference from an LLM to generate malicious Lua files, which it would then execute upon receiving them.
That sounds already like a lot of techniques involved. Can you start with explaining what Ollama is?
Yeah, Ollama is an inference endpoint. What that means is that it's the software that runs on an AI-capable endpoint, either with large GPUs or with a heavy-duty CPU, and it actually turns a prompt given by a human into the necessary components to do inference on. Inference meaning the querying of a large language model to do something, in this case, just text generation.
Okay, and so that means, and you already mentioned it, you need also an LLM for it. Was there a specific LLM being used for this? This Promptlock?
Within the malware, the researchers found the entire JSON that would be sent onto the Ollama server, and according to the Ollama spec, that request would include a model parameter. And in this case, the model parameter was set to GPT OSS 20 billion. That's the new open source model released by OpenAI. The 20B just stands for the 20 billion parameters included in it.
Okay, that makes sense. So we have now a component compiled by Go that will do a call to the Ollama, which can make use of an LLM. And then as a result, so probably the initial request was, hey, I want the result as Lua code. Can you also explain what Lua code is?
Yeah, Lua is just a programming language. It's interpreted just like Python, meaning that there's a specific binary that executes the Lua code, so it's not directly compiled to machine code. So yeah, it's an interpreted programming language.
Okay. So that also means I can imagine that it can be really dynamic. So in this example, it's all Lua, but I can imagine that in the future, a tool that uses the same techniques would say, okay, but I'm now on a Windows machine. I want this script in PowerShell. Or I'm now on a Linux host. I see Python installed. Can you give me the script in Python?
Yeah, exactly.
Okay, that makes it really flexible, I think, for an attacker. Yeah. And very dynamic. And unfortunately for us, a bit harder to detect.
Yeah, definitely.
Okay. But luckily for us, till today at least, Promptlock seems to be a proof of concept founded by Asset, if I'm not mistaken.
Yeah.
How do we know that this is a proof of concept and not just an actual malware that's being used in campaigns?
Well, there are a few indicators of that. The biggest red flag, or I guess green flag, was the fact that the strings of the malware contained a Bitcoin address. Now, that's commonly seen in ransomware because the target needs to send their money somewhere. So it's usually a Bitcoin address or some other cryptocurrency address. But in this case, the Bitcoin address was belonged to the original creator of Bitcoin,
Satoshi
Nakamoto. So it wouldn't make sense for an attacker to include that address in their malware if they actually were gunning for funds to be received.
Yeah, it will all go to Satoshi.
Yeah.
So unless he is the creator of the malware.
That would be a great plot twist, yeah.
Would be a nice twist indeed. Okay, so a lot of things might change now in this landscape. Very dynamic attacks. How can we defend against this?
Well, first and foremost, the cybersecurity community will have to start transitioning off of static indicators as soon as possible. The most popular method of indicating malware is based on file hashes, SHA-256 hashing. But that won't work anymore because of the deterministic behavior of LLM. If you ask it to generate a script to do something malicious, the second time you might ask the exact same thing will give you a different return, meaning that hash-based fingerprinting just won't work anymore.
Okay, so also the sites like VirusTotal, for example, need to change if they want to track all these kinds of attacks.
Yeah. There are already methods in place for this. You have malware families, of course, where you can not identify, but you can at least talk about malware very easily by just specifying the name of the family of malware. But you're still going to have to find a way to detect the malware initially. And so we're going to have to move over to more dynamic detection solutions like behavioral analysis or just dynamic malware analysis in sandbox environments. Fingerprinting and hashing just won't cut it anymore.
Okay, that makes sense. But so then, if you talk about behavioral analysis, I quickly think about EDR solutions, XDR solutions, running on the endpoint, detecting any abnormal processes, abnormal behavior. So I think that's a good step, but it's also a step I would say everyone should already do at this time because, the static signatures are already I would say, lacking.
Yeah.
Things are evolved so quickly. Are there any other things that we can do?
Not a lot. The thing with behavioral analysis is the content of the payload that might be generated by AI will never be the same based on fingerprinting, but it should still perform the same amount of steps that a regular self-written piece of malware would do. It would still need to check certain commands or process information to determine the OS it's running on, the CPU architecture, things like that. We'll just have to rely on them a lot more.
Mm-hmm. Okay, and for this specific malware at least, or this proof of concept we saw, you said it needs to access an Ollama server or Ollama instance.
Mm-hmm.
Can we detect that?
We could. It would require SSL decryption and inspection because it is just an API query. So it's all going via HTTPS. It's all just encrypted traffic. So you're not going to be able to determine whether or not some random post request is going towards an Ollama server without inspecting the actual contents of it.
Yeah, so unless we know that the destination is on an indicator of compromise list, we really need to decrypt, look into the traffic, see, hey, these API calls are going to an Ollama server.
Yeah.
Which then probably indicates that that's not wanted.
Mm-hmm. Yeah.
And we want to block it, unless, of course, you have some valid use cases for that.
Yeah. But for Promptlock, there's an easier method of blocking it, and that's obviously to just block the execution of Lua scripts. Yeah. Wouldn't make sense on a random user endpoint to run Lua scripts anyways, so that's just low-hanging fruit to block, but there would still be methods around that, most likely.
Okay, yeah, we discussed that before. If you really talk about security, then also make sure that the user is not able to execute, for example, PowerShell or Python, or in this case, Lua. Mm-hmm. Question in this case would be, on most systems, Lua won't execute because you need that interpreter. Mm-hmm. But yeah, block the access to those tools would certainly help. Okay, any other things that you can think of?
No, not really. It's really just either behavioral or based on network indicators, but those already also require foresight of other attacks.
Okay, yeah, I would say, but that's go a zero trust approach. Not servers, for example, often don't have to go outside, so you block everything.
Yeah,
it's not specifically for this attack, but it will help in general.
Definitely.
Okay. So the question now is, we now have this proof of concept. What will be next, and what timelines are we thinking of?
Well, Promptlock was already quite dynamic. It would generate those Lua scripts. Those Lua scripts would enumerate the local file system and would try to find interesting tidbits of information. And then it would go on to determine its next steps based on what the previous script found. So if it would found that it's running on a Windows Server 2008 endpoint, it would know it would do something differently than if it was running on just a regular user's endpoint. We already saw that it would determine dynamically whether or not it would try to ransomware the host by just encrypting everything, whether or not it would start destroying files, even though it couldn't yet because that wasn't implemented. Another indicator for it being a proof of concept.
Or steal the information, I believe, was the other.
Exactly, or exfiltrate all the data that it found that it thought was interesting. So it was already super dynamic in its execution, but what we're going to start seeing with other AI-powered malware is even more dynamic steps. It could feasibly start looking into what kind of OS am I running? That's low-hanging fruit. But also what kind of antivirus software or EDR is running on this? What other applications can I find? Can I find known vulnerabilities for the application? Do they have proof of concepts? Can I exploit them? And then even just generate exploits for those vulnerabilities on the fly without anybody having to do any investigation into the target. Could do all of these things super dynamically and just on the fly.
Yeah, that makes it quite scary because we know there are some ways to bypass an EDR. We also did an episode on that. Mm-hmm. But now, in the current state, an attacker needs to know what EDR you are running, needs to prepare everything for it. You have to make sure that this payload is able to disable that EDR solution. Mm-hmm. But what we might see then is new malware coming into your system and just asking or checking what EDR is running and then asking to the LLM or saying, okay, I want something that disables this specific EDR solution, and then probably he gets a script or a way of doing that.
Yeah, instead of a cyber attacker deploying malware and just waiting for like a C2 beacon, it could almost feel like you have an actual attacker inside of your PC, even though it's all fully automated and doesn't require any input from anyone at all.
Okay, yeah, so it's not the creativity that normally a pen tester would bring, but it is somewhere in between what we have now, very relatively static, and complete creativity. It's somewhere in the middle, but it also means it's very unpredictable.
Exactly, yeah.
Would it be maybe also a benefit to us as the defenders that it also is less predictable for the attacker, do you think? Or
sorry, could you repeat that?
So is it also as a benefit for us that the outcome is always different? So also the predictability for an attacker is less than it has today. So
I wouldn't really know how to answer that, because on the one side, unpredictability could lead to more obvious behavior, meaning that it would become much easier to detect. But on the other side, unpredictability could also just mean that anybody looking into the behavior of a process wouldn't know what the hell is going on. So it's a double-edged sword. It can work both ways.
Okay, yeah, that's a fair point, I think. Okay. About timeline, do you have any idea when these new malware would become a reality?
No. I mean, if you look back during COVID, when ChatGPT started doing its thing, I think not a lot of people could have predicted that it would blow up and start to become so commonplace now to use AI tools right now. I think most people would have thought it would have taken at least another couple of years. With this, yeah, I mean, it is a proof of concept. It is new, but to me, it's kind of like the 5-minute mile, or the 5-minute mile, where nobody did it, and then one person did it, and then everybody did it. I think we might see something similar here, where because it is now proven that it could work, we're going to start seeing groups actually actively trying it in the short term.
Okay, I can imagine that maybe the requirements for running your own Ollama with a decent large language model might hold back a few people, because it's not easy to set up. You need a lot of investment. But once it's out there, once you have set it up, I think
that's also becoming a lot less complicated. With a generic consumer-grade GPU, something that you could use for gaming, that specific GPT OSS 20 billion parameter model, you could run that easily and have pretty decent speeds in text generation. So already the hardware requirements are pretty low for this, and I'm assuming cyber attackers, APT groups especially, nation-state attackers will definitely have more than enough resources to perform these kinds of attacks.
Okay, so once they get used to these kinds of techniques, we might see them popping up every day.
I think so.
Starting within maybe even a few days.
Yeah.
We don't know.
Let's hope not.
Let's hope not. Let's hope we have a little bit more time to prepare. But I think that brings us to a conclusion here. So that Promptlock really shows us what is possible. It's not sci-fi anymore. There are really a lot of capabilities, just as kind of a preview of what's coming. But maybe it's already tomorrow's reality. So with that, thank you, Yuri.
Thank you for having me.
Thank you to the listeners. If you like what you saw, don't forget to like and subscribe. That really helps us to spread the word further. And with that, thank you.
Thank you for listening to Threat Talks, a podcast by Onto It Cybersecurity and AMS-IX. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.